Hello everyone and welcome to Jumperman Tech, where we specialize in HVAC but do everything DIY, and today I'm going to show you how to troubleshoot a 3-phase motor. Thank you to everyone tuning into Jumperman Tech. If you find this video interesting or helpful, please drop a like, comment, and subscribe, and let's get straight into it. Once you have determined you have no control issues and your starting components are operating, it's time to dive in a little deeper and troubleshoot the motor itself. It's always important to look at the tag of your motor to understand what kind of motor you're actually dealing with. Here you can see this is a 3-phase motor as well as a dual voltage motor. This can be wired for 208 to 230 or 460 volts. You also want to determine that this is wired properly before you actually move on. Safety is always first, and when performing this test, you're going to want to make sure that the power is off. From here, we can take off our cover plate. We always want to make sure that our motor is the correct one for the application, and we also want to make sure that it is wired properly for the correct voltage. Assuming everything is okay, we can move on. From here, you're going to want to isolate your motor by disconnecting all the wires so we don't have any feedbacks. We don't want any wires in our way, so we're just going to take that and just pull it to the side so we don't get any feedbacks. As you can see, we can read L1, L2, and L3. This right here is L1, this right here is L2, and this right here is L3, and these are the points that we're going to be checking. In this case, we have 3 terminals to check, or you might have just wires coming out. Regardless, the principle remains the same. For the most accurate reading, you're going to want to use a megameter, but with today's technology, it's not exactly needed. Today, I'm going to be using a multimeter, and I'll be using the Hvac 902 FC HVAC clamp meter. We're going to be checking the resistance of this motor, and we're also going to be checking for any grounds. So to begin, we're going to set our meter to ohms, which is this lower symbol here, which measures resistance. And on top, you could actually see we have a symbol for continuity. At the same time, my meter reads both. With continuity, we're going to get an audible sound, and with the ohm reading, we're going to get a detailed reading. I'm going to put the light on with my meter so you guys can see. It's going to be hard to capture everything all at once, so I want to explain what I'll be doing. We're going to be checking the resistance between any 2 of these points. So we're going to start with L1 and L2. Then we're going to check between L1 and L3. And then we're going to check between L2 and L3. Any combination between any 2 points, basically you're going to be looking for the same resistance reading. I have my meter set to ohms and continuity, which in my case is both, but with your meter most likely it's going to be separate. But here you can learn both ways. So the goal here is to get continuity between any 2 combinations of these 3 terminals, and at the same time we're looking for the same resistance between any combination of any 2 of the 3 terminals. So let's begin. I'm going to start with L1 and L2. We had an audible sound, which means we had continuity. That's good. And we had a reading of 2.4 ohms. Next, I'm going to do it between L1 and L3. We had continuity, and we had an ohm reading of 2.4 ohms. So far, so good. Next combination would be L2 and L3. We had continuity, and we had an ohm reading of 2.4 ohms. So between any 2 of the 3, we got continuity with an audible sound. That is good. Between any 2 of the 3, we got an ohm reading of 2.4 ohms, and this motor checks out because that is exactly what we're looking for a good motor. If between any 2 of the 3 we did not have an audible sound, that means we did not have continuity, that means that your motor is bad. If between any two of the three we got a reading of OL in ohms, that means infinite resistance or open circuit, and that means your motor is bad. If we actually got a reading but it was in kilo ohms, it's basically the same thing as OL, and your motor would be bad. One thing you must take into account is the temperature of the motor before performing any of these tests. Many motors come with internal overloads that we cannot see, of course, because it is internal. This is a safety device that if your motor overheats, it's there to protect by opening the windings. What we're actually checking in this motor is essentially we're checking the windings, we're checking the insides. So let's say your motor overheated, your windings would be open. So you would check your readings and you might get OL or a reading in kilo ohms, and you might be mistaken that you have a bad motor, but in reality, it's just your safety device that opened up. So you're gonna wanna make sure that motor is not burning hot to the touch or way above its rating temperature level. You're gonna wanna give it some time. Make sure it's about room temperature or the area's temperature before you check the motor, so you do not make that mistake. Next, we can check this motor to see if there's any short to grounds. So we're gonna set our meter to continuity or ohms. Personally, I like to use an audible sound. It just makes things so much easier. So what we're gonna do is keep one lead on any one of the terminals and then touch the casing of the motor anywhere here or even like above over here. If the motor is like super dirty, you might want to take like a piece of sandpaper so you get a good reading, but regardless, this is what you're going to be looking for. You're going to put one lead on L1 and touch the casing. If you have an audible sound, then you're grounded. No audible sound, you're good. Next, you're going to put one lead on L2, touch the casing of your motor. Once again, if you have an audible sound, you're grounded. If not, you're good. Then you're going to put one lead on L3, then touch the casing. And if you have an audible sound, then you're grounded. If not, then you're good. Next, to check this for resistance, what you're looking for is an OL reading. You do not want a resistance reading. So if you put one lead on one of your terminals, touch the casing, and you have OL, then you're good. L2 to the casing. If you're reading OL, you're good. Next terminal, L3 to the casing. If you're reading OL, then you're good. If you would read resistance from any line to the casing of your motor, then you're grounded. Or if you were using continuity once again, and you check from one leg to the casing of your motor and you heard an audible sound and you have continuity and you're grounded. That's how you check. Another thing you want to take into account is to see if your shaft freely spins. If you have a lot of resistance, you're going to want to make sure to see if there's any Zerg fittings around so you can grease your motor. Some of them have that, some of them don't. If it spins freely, that's cool. And if you can't spin this at all, then your motor is seized as well and it needs to be replaced. And that, ladies and gentlemen, is how you properly check a 3-phase motor. If anybody found this video interesting or helpful, please drop a like, comment, and subscribe, and I'll catch you all next time.